So here's a video on the idea of a tangent line. So I have a blue curve here, and I have a straight line which is red. What I want to notice about this is that this red line sits on exactly one side of the curve at this particular point. This point right here is called a tangent point, and this line here is called a tangent line. So if I move this point, you can see that the slope of this red line changes. The steeper the graph, the steeper the line. Now, if I go to the very top of this thing, I'll find out that this is a horizontal line, or almost a horizontal line if I can move it just correctly, just like that. So locally, in other words, just in a small region, don't worry about things really far out here. Just look at local. This line is completely above the curve. Now, if I move this point, what we'll notice is that this intersection point out here, where I told you don't think about, but now take a look what's happening. As I move this closer, the point and the intersection point, they coincide with each other. And as I move this point all the way over here again, now the tangent line is completely below the curve. Again, don't look at points very far away from the point in question. So what is all this? Well, at this specific place where I am here, in this general region, we gave this shape a name. We called this concave up. And in this region over here, we called this curve concave down at this. So what happens between concave down and concave up? Do you remember what that was called? It's called the point of inflection. If I put our tangent point at the point of inflection, we see that the tangent line cuts the curve. It goes through the curve. On one side, it's above the curve, and on one side, the tangent line is below the curve. So a tangent line, except at the point of inflection, it touches the curve and doesn't cut through it. And that's the idea of a tangent line. I hope this video is helpful. Bye.